moved on to a different topic now at this stage. If you recall, or if you did not know, that the multiple choice questions and on paper one and the questions on paper two are laid out in chronological order. In other words, in order of the topics that you would have studied. So at the beginning of this paper, we were looking at topic one, stoichiometry questions. Then, if you recall, we looked at some atomic structure questions. And now we're into topic three, which is all about periodicity. So in this question here, we're trying to identify which one of these oxides, these metal oxides or non-metal oxides, will produce the most basic solution, because we want the solution with the highest pH. So we want the most basic solution. Remember, there's an inverse relationship there. So when we talk about the pH scale, just to remember, it goes from 1, or in some cases they would say it goes lower than 1, 7 for neutral, and then a maximum of 14. So when you're up at pH 14, that's the most alkaline or basic. Most alkaline or basic. A base technically is when you're talking about the solid form of the compound, whereas alkaline is when you're referring to the solution. But in any case, this is a solution or a solid which will give you a very high pH, and that's what we're looking for in this question. Acidic solutions will give you a low pH. So acidic solutions will give you a low pH. The pH scale is inversely proportional to the concentration of H plus ions. So just remember that. So the more H plus ions you have, the lower the pH you have, and the less H plus ions you have, the higher the pH you will have. So I just have written my key to the question up here is to remember your trends in the period 3 oxides, because this is something the IB like to assess a lot for topic 3. And they teach you specifically about period 3 or row 3 on the periodic table. So know this trend. And the trend is effectively this. The first two groups are going to make alkaline solutions. Alkaline solutions. As you move across the periodic table, you hit the element aluminium. Now, aluminium is what's known as amphoteric. Amphoteric, as opposed to the other very similar word, which is amphiprotic. Now, don't mix up amphoteric with amphiprotic, because they also like to ask that in multiple choice questions too. So aluminium is amphoteric in the sense that it can act as an acid or as a base, depending on what's being reacted with it. But think of aluminium as that transitionary element between the alkaline elements to the left of it and the acidic elements to the right of it. So the other elements we're considering in this question, we have sulfur here. So we should know from your periodic trends that anything with sulfur in it reacted with water will make an acidic solution. So this is going to make an acidic solution, which is not what we're interested in, because that will have a low pH. And the other element we have there is carbon. Now, carbon is not in period 3, but it's above here in period 2, and it's still in that same area of the periodic table where it's to the right of aluminium, and therefore that's going to make an acidic solution. Now, you should know about carbon's reaction with water, carbon dioxide's reaction with water to make carbonic acid as the weak acid that's naturally in acid rain, rain which just has carbonic acid is normal rain. Anything with a pH lower than carbonic acid is considered acid rain. And that's from topic 8. To go back to explaining fully why the answer is going to be sodium for this question and not magnesium, for example, we're going to go through the equations for each one of these reactions just for you to get some practice writing simple equations and balancing them. Okay, so I've just written out the 4 compounds in question here, the 4 oxides that we're considering reacting with water, just to speed things up a bit. But we're going to add water in all cases, so you can start doing that. And there's no easy way really to learn how to balance equations other than to practice doing them. And I've had the best of students that I teach that can get very good marks in higher level or standard level, but they often struggle with balancing equations because it only sort of pops up now and again. Most of the time the equations is applied for you in the questions, but it's a mark that you should be picking up if you consider yourself a fully competent chemist. So to remember here, all of these oxides will either produce an alkaline solution or an acidic solution. So we said that sodium and magnesium are in groups 1 and 2 on the periodic table, as we spotted up here before, And so therefore they should be giving us alkaline solutions. Now the IB are not expecting you to know obscure, tricky alkaline solutions that you've never seen before. These are classic alkaline solutions that you would have seen many, many times, even all the way up through junior science. Sodium oxide and water will make sodium hydroxide. Now, if you've never heard of sodium hydroxide at this stage, then that would be a bit concerning. So sodium hydroxide is formed, and you just have to balance the thing out. So you stick a 2 on there, and you're sorted. So that's 2 moles of sodium hydroxide solution will be formed when sodium oxide reacts with water. The next one down, we look at the other alkaline solution, and just magically I've used blue pen here for the alkaline solutions, so I'll try and stick to that. And magnesium oxide and water will make magnesium hydroxide. So there are 2 hydroxides needed for every 1 magnesium because, of course, it has a positive 2 charge. So we stick a 2 on there, and it looks like it's balanced. So this is also an alkaline solution represented by the blue color. Now, just to stick to that little model, I'll use the red then for the acidic solutions. So sulfur, we said, was to the right of aluminium, so therefore we'll make an acidic solution, and also carbon is to the right of aluminium, so it will also make an acidic solution with water. So sulfur trioxide and water, this is one of those intermediate steps that you need to know for topic 8, the acid topic, topic 8, acids and bases, where they like to talk about acid rain formation. So sulfur trioxide in the air reacting with water will make sulfuric acid, H2SO4, which of course is a very strong acid, and that is already balanced there. It's one of the easier equations you could write, but that's acidic, and we're not interested in acidic solutions because they have a low pH. That would be a very low pH, so we can discount answer B, discount that answer. And then the fourth one here, carbon dioxide and water, as I say, it's a classic equation that you need to know for that topic 8. And that's the reaction of that carbon dioxide gas with water to make carbonic acid, H2CO3. Now, again, that's balanced. So that is also a low pH. Now, the pH of carbonic acid is nowhere near as low as sulfuric acid. It's a number you should remember of 5.6, approximately 5.6. So remember that number for carbonic acid, because anything lower than 5.6 is considered acid rain. So we've narrowed our answers down to either sodium oxide or magnesium oxide. Now, the final answer for choosing the best one in this case, which is the sodium oxide, is to consider how reactive the metal actually is. So sodium is far more reactive than magnesium. Sodium is that classic demonstration where you take a little piece of sodium metal, you put it in some water, it fizzes, it jumps around the top of the water, you might even get a little bit of a yellow flame from it. You put some magnesium in water and it does nothing. It floats on the top and it does nothing. So sodium is far more reactive than magnesium. So sodium is going to be quicker, faster, and will produce more of the metal hydroxide in solution than the magnesium metal. And for that reason, then sodium, because it's more reactive, will make the more alkaline solution. The reason I'm making that point is because in both cases, you get 2 moles of hydroxide ions produced from the sodium hydroxide, or the magnesium hydroxide also produces 2 moles. But the sodium hydroxide will produce it faster, more aggressively, and more completely.